Howdy, this is Jim Rutt, and this is The Jim Rutt Show. This is The Jim Rutt Show, and I'm your host, Jim Rutt. My guest today is the thinker, writer, and doer, Bonnitta Roy. I usually give a brief bio, but Bonnitta's life and work are so multifaceted and always changing. I thought it better to ask her. So, Bonnitta, why don't you give us a mini bio?
First of all, thanks for asking me to come on your show, and thanks for turning the tables on me, so I have to introduce myself, and it can be difficult for me too. I think at the fundamental level, I call myself an insight guide, but I also work toward trying to get novel insight. So that's something I wanted to talk to you about, as we were discussing earlier, that sometimes people are confused about what I'm trying to do, what I'm trying to say. And because I was coming on this podcast, I really spent some time trying to clarify for myself what it is, how do I fit in this space. So I thought we could talk about it. This would be my first time of talking about myself this way and kind of throwing it out there. And hopefully that'll be fun for you, because I know you're interested in new ideas also. So
Absolutely.
What I want to frame myself is interested in insights. So unlike some of your other guests, I'm not an expert in complex thought or complexity science, but I'm interested in what are the limitations of complexity science? Can we push those limitations so that we go even further? What are the fundamental assumptions that maybe constrain complexity science? And one of the things that I've had insight into is that I think that there's very few complexity scientists or complex thinkers who have integrated what I would call process thinking into the complexity sciences. And I actually Googled that this morning and found the only intersection between those two in Google Scholars was my own work. So it started to really crystallize for me just recently that that's perhaps why process philosophers don't really get me and complex thinkers don't really get me, because I'm actually trying to see how these two approaches to thinking, approaches to science, approaches to philosophy can stretch each other into something new. So that would be an example of how I'm always working with the information science or the systems thinking, not just to work with it, but to understand it, make it an object of inquiry, and see if we can move these boundaries into a different approach that may be more profitable for addressing some of the problems we have today. So this integration of complexity thinking or complex thought and process philosophy is what makes my work different than some of the other people's work in the space.
That sounds really interesting, because I think, as we both know, whenever you draw a circle around something, call it complexity science, not only do you restrict what's in, but you also build an artificial barrier to what's outside, right?
Yeah.
So taking any given circle that one's drawn around some arbitrary area of content, and then looking at how that intersects with what's outside of it is often very generative. Let's just hop right into it.
So I would say here my role is going to sound like I'm a process thinker beating up on complexity science, but it is also true that very few process thinkers, and what I mean by that is a la Whitehead and Griffin and Hartshorne and the whole school, very few of them have managed to stretch outside of process ontology into complexity science. There's a lot of resonances, so I don't think the stretch is that hard, but like you said, people tend to put themselves in a box or build a boundary and then navigate through their thought on the basis of the assumptions that are defined by that boundary. So just saying that, just so you know, it's going to sound like I'm beating up on complexity theory, because I'm going to represent more the process space here, and I think you can represent the complexity space better. They tumble over each other. They both have very important ways to inform each other. So that's, hopefully we can proceed that way.
Yeah, that sounds great. I love active engagement at the boundary between areas, and sometimes that's the most fruitful areas for investigation.
Yeah. And so then in general, what we're going to be doing here, Jim, if we can pull this out, is a lot of thought experiment and a lot of hybridization, and I would call that insight practice. because we're actually trying to have insight into the ways, the perspectives we're taking, the assumptions we're making. We're looking at the architecture of the thought we're looking through. These are all complex metacognitive skills, which I think is a feature of most of the guests that you have on this show, that we're capable of doing that. So this is really cool. So the first thing I would say, and some of this is not generous, I'm just trying to clear out some territory for the audience, and then you can say, but complexity science does do this and this thing. So some of it's not generous, and we can build up from there. So for example, a lot of complexity science has this problem that process philosophy is very wary of, and that is reification. So that, for example, when we're thinking of a certain type of systems, we reify it as if it has a boundary, that it's an object that can be manipulated, that I can act on the system either by observing or experimenting with it, and yet it doesn't act back on me. So this is a process of reification that process philosophy would have a yellow flag for complexity science. And so, for example, it's very hard to think of light as a wave without thinking that it propagates through something. Right? There's a whole history of the science of whether light had an ether that it propagated through the same way sound propagates through air. So in process philosophy, we would say the tendency toward having a subtle mental model that there's an ether that light propagates through, that's the third term. That's the reification of a third term. And process philosophy is more comfortable with just understanding that, light moves, or light is movement, or it is propagation. And so it's kind of the same move that Einstein made, where instead of gravity being a force, which is like a third term, like something you could go look for, he saw it as just the relative motion of different inertial frames, right? So you see, this move in process philosophy is to go to the point where everything is in motion with respect to everything else. Nothing is deanimated. There's no privileged position outside of the system in which you can look at it. So it increases the complexity, and it kind of unbounds the complex space in a way that requires a level of sophistication that I think is demanding.
That's interesting. Let me reply to that. Let me see if I get what you were saying correctly. Again, in kind of pushback mode, I'll suggest that what you described strikes me as exactly what science ought to be, which is model building, right? Anyone who tells you that science proves X, the person's not a scientist, right? Because science never proves anything, right? Prove, right? What it does is has, contingent theories that have not been falsified by experiment, that are the best knowledge we have at the moment, but if we look at the history of science, we're almost certain is incomplete and or partially wrong. So I think that really the job of science is to build models that have as much congruence with reality as we can, and use those models to tell us something about reality. And then other people take those models, technologists, and say, all right, how can I use those models to actually create some action or a leverage in reality? So I would push back a little. What you say is interesting, and that there is more to be said than just science. But within the container of complexity science, I would map the term reification to model building. And that's what I would say is the main job of science.
Yeah, so that pushback is completely 100% received, because I agree with you. I think that as long as we understand that we are constructing models and they're useful and they're relevant and they carry us forward, if we understand that we are in the process, we are participating in the construction of this model, but it doesn't stop there. It's like a stepping stone. And then from there, we can ask new questions, we can have different insights, and we can carry the enterprise of science forward, not only as a technology, but as this double step between insight and action. And I think action is definitely a requirement, because effective action tends to simplify the search space really fast. So I tend to sound like a complete theoretical person, but I'm glad you introduced me as an action person too, because when you're working in these complex domains, it's the action in the world that can clarify and simplify through model building and action what the hell's going on.
Truthfully, that's what it's all about, really, is action in the world. I think we both also have an interest in the science of consciousness, or consciousness more broadly in your case. And my argument is consciousness is nothing but a tool to help us more effectively have action in the world. And science is another tool. One of the markers I want to put down, and it might help us have our discussion without unnecessary conflict. Useful conflict is good, but unnecessary conflict isn't, is that I am not a scientific totalizer. I don't think everything is science by any means, right? And you hear this argument against science, scientism, some people call it, that people try to totalize science. And yeah, I'm sure there are people that do that, but I don't know any first-class scientists that do that. Science is this thing. It's a box. It's a model building that has congruence to reality, that looks for data and experiments to falsify the models, and then create new models or improve the models so they're not falsified. And that's what science is. Science is not technology, right? It's very interesting. Technology existed long before science, right? The invention of the plow, the invention of agriculture, the invention of the water wheel. Now, science has amazingly accelerated technology, but it is a separate domain. And so the doing is not science. Science builds the models, and then doers of various sorts, whether they're technologists or general empiricists. I consider technology to be a subset of general empiricism. And so we then have technologists and other classes of doers, of which there are many other classes, including organizational design as an example of a class of doing that isn't really technology, at least not in the hard sense. Though, in the sense of taking scientific models, let's say our models of cognitive science, and putting them to work, one could argue that organizational design is a form of technology. So with that as some boundary setting, why don't you go on?
So a whole bunch of things. I have like 4 little word clouds here that came out of that. So in terms of complexity science, what you've said, I think, highlights the role of action in complex domains. So if we look at some of the tools that scientists have relied upon in the past, classical science, we make if-then propositions, then if-then propositions can create hypotheses, hypotheses can establish experimental design, and then we can test those if-then propositions. But when we get into the complexity domain, something really interesting is happening with causality. Let's just keep it at that right now. Maybe you want to comment on that. And these easy if-then propositions start to break down. They're not adequate to facing complexity. And so what we see with people that are working in the complex domain is this return to action and probing and sensing. These are all words that we associate with the body and empiricism: observation, action, probing, sensing, pattern recognition. And you start to see science as returning or evolving to more roots in action, sensory motor action. And that's interesting that the way you kind of put what I was saying before together and highlighted actions, almost like we're being pushed now to rediscover the domain of inquiry that has to do with our sensory motor perception capacities. And maybe you could comment on that.
A lot of good things. You talk about causality, one of my favorite topics. And this is where complexity science really does open up a whole new field of inquiry. And I like to point out to people that, at least to my mind, the gateway from previous reductionist science to complexity science was the mathematical field of deterministic chaos. If you actually look at some of the people involved in the earliest pre-work in complexity, many of them came through deterministic chaos. And for the members of the audience who don't understand or don't know about deterministic chaos, it essentially means that in systems of even surprisingly little complexity, but some level of complexity, that are entirely deterministic, the actual trajectory of the system over time is very, very, very wildly based on the initial conditions. So that while in theory, the old Laplacian Newtonian model that, if I knew every position and every motion of every particle in the universe, I could predict all of time going forward, in theory, even if that were true, which it probably isn't, then deterministic chaos means it can't practically be done. Even an extraordinarily simple system like the Lorentz attractor or a 3-body problem in orbital mechanics, the tiniest difference in the initial conditions, way below the level of human capability to measure, results in very different trajectories. So it basically overthrew that Laplacian view of the world as mechanism, at least from a practical perspective. And that's basically just math, right? It turns out that you can mathematically show deterministic chaos in very simple systems. So then that basically led to, okay, what else does that lead to? And in this case, it basically, to my mind, said that causality is way slipperier of a concept than we thought it is, right? And as we've exposed and explored in complexity science, we've run into two kind of related phenomena. The first is emergence, right? Still the biggest question in complexity science. What exactly is emergence, and what can we really truly say about it? What can we say about it that might actually be useful for the applied people to cause emergences of some sort that are useful in the world? And essentially emergence, again, for folks, is how do very low level phenomena somehow promote themselves to higher level of phenomena. Let's take life, an organism, as a fine example of an emergent property. At the bottom, you and I are both just atoms jingling around, right? And somehow those atoms become embedded in chemistry. They turn into molecules, create basic chemistry. The basic chemistry is involved in a very complex network of biochemistry, which eventually results in metabolisms, which then results in cells. Cells organize and classify themselves as tissues. Tissues become organs. Organs become systems. Systems become organisms. And organisms are embedded in ecosystem. And emergence, what's that all about? When we get to causality, one of my other favorite slippery topics is top-down causality. What the hell could that mean? So in the case of the human, one could say the fact that some specific atoms in, say, one of your red blood cells is contained inside of a ecosystem, a organism, tissues, systems, etc., means that those atoms will behave very differently than they would if they were just on their own floating around in, say, the ocean. And so one could say that the cause of the behavior of those atoms is considerably constrained and defined. Define's too strong a word, but let's say constrained by the fact they're embedded in this hierarchical tower. So I guess that would be my first response.
So this is great, because this is where complexity thinking cues in process thought. Now, relational process thinking is, as complexity is, it's a epistemic discipline, so we need to try to integrate them. So process thinking would say that the paradox of emergence and top-down causality comes from the limitations of complexity thinking. So let me reframe that and see if we can work with these two concepts in a way that we don't get these kinds of conundrums that you so well articulated. So for emergence, for example, we can look at when you tackle the problem of emergence the way you do and you construct these larger and larger levels, this is something that process philosophy would say is you're reifying the larger system. So how can we work with emergent systems, let's say, just using that as a placeholder, and not do that? So one of the easy ways we can do it is we can say that there are developmental processes and there are evolutionary processes, and every agent that is developing its own creative advance, it's doing novel things, it's probing, it's bumping into things. It's doing that within a developmental field. The human body is the developmental field for the molecules. The same molecule in a different kind of environment is going to exercise different affordances. So you're going to get patterns, emergent patterns that are different because you have action inside developmental fields. Now, it gets more complicated than that because the developmental fields themselves are also evolving. I mean, this is kind of what Stephen Jay Gould says, that organisms develop within developmental fields and the developmental fields evolve. And he argued that with these two, if you really understand the two pattern dynamics, the two dynamics and how they relate to each other, then this is what emerges. So he would say that emergence of new species happens because you have developmental potentials that are codependent upon the fields in which they're developing, which changes and evolves a developmental field. So you get changes that are are no longer progressive and developmental, you get changes that look like leaps. And that's what emergence is. It's a change that doesn't look continuous with the micro states and the micro changes from which it arises. And that's because there has been a change in the field in which those protocols or actions have been taking. And so just working with evolutionary developmental theory, which tries to use both these dynamics, I think helps explain some of these logics of emergence that we're trying to deal with instead of stacking them up like levels of a train or something. It's the same thing with top-down causality. Process philosophy would say that the human is the third term. The human is not this top-down agent that then looks back on its own system and makes decision for it. The sense of being a human or an individual agent is already a result of the microstates and the micro actions in all these various levels. It is an outcome or a product of its own generative arising. So you have to train your mind not to say, but then I can get up and walk across the room. But the whole I can get up and walk across the room is itself arising from these micro states and micro potentials and the evolving landscape of my body as a developmental field for all its participants. So we have to be careful too, because I can use the term developmental field and I don't mean an external environment. I mean the patterns of engagement of all the participants that I can assign as a stable enough pattern to say my body and in reality, the more I investigate, the further out into the world I have to go. And so I'm exchanging oxygen with other plants and animals, and the environment that oxygen or that air is in is also developmental field, and it goes on and on. There is actually, once you get going, no boundary, but just for the purpose of studying or talking or investigating, we have to try to use words that are placeholders for open participation in the whole.
Very interesting. I wouldn't say there was anything that you said that I firmly disagree with. And in fact, I think it was mostly a different lens on the same thing. I think there were some things that you missed that I'd like to bring up and get your reaction to. First, talking about reification. I think in science, we often call that coarse graining, right? The world is essentially continuous and infinitely variable at low enough level of analysis. But to say useful things, it often is important to coarse grain because, for instance, trying to define how a 777 Boeing jet works at the level of atoms is impossible, right? Literally, it would take, if turn the whole universe into computronium, i.e. the highest possible effective computer, you still couldn't simulate it at that level. It's practically impossible. So instead, you have to look at it as aerodynamics at the level that a wind tunnel can do, or a computer simulation of a wind tunnel. You talk about combustion in the engine at the level of combustion engineering. The driving of the turbine at the level of kind of the intersection of combustion engineering and airflow dynamics, et cetera. And so, going back to our model example, call it a human or a mammal, doesn't really matter. There are some clear, to me at least, useful and important reifications, if you want to call them that. I'd call them coarse graining, that are relatively clear cut. For instance, in the biological stack, a cell is pretty damn clear cut, right? It's what's inside the cell membrane. And it's also can be looked at thermodynamically, the rate at which chemicals interact with each other. Those inside the membrane interact at a much higher rate with each other than they do with those that are outside the membrane. And indeed, what the membrane is a semi-permeable membrane, which allows a certain amount and at a certain rate of chemical flow between the inside and the outside. But both mathematically and physically and functionally, you can say that this line of the cell membrane is a very useful coarse graining, and the world inside and outside are very different. Next is the individual. It's going all the way up to the top, nearly the top of the stack, which is an individual animal, to my mind, is quite well defined. I mean, this is an argument I remember having at the lunch table in junior high school with a couple other smart nerds, right? Is what is life? What really is me? And over the years, I've heard lots of blather on the topic, and I've concluded that it's actually pretty sharp, that one could say that me is that stuff which is in biochemical homeostasis on the time order of a second or two, i.e., that part which is exchanging oxygen, removing CO2, delivering nutrients, etc., on a time scale of a second or two. So, for instance, that model says my fingernails are not me. They are not receiving nutrients and oxygen and are not part of this, 2-second time frame homeostasis. Neither is my hair, but my hair follicles are. So it's actually a coarse graining or a reification, you want to call it that. That's actually very useful. I can now say, this is me at a very high level of precision.
I don't want to extend this too far out because I have two things that I want to say that are important parts of process philosophy. I mean, this conversation is great because for what you just said, process philosophy has this notion of duration. So you were talking about temporal frames of bioseconds or something like that. And in process philosophy, an agent can be identified by the duration of its arising and falling. So like a proton has a half-life, it has a duration. So in process philosophy, the scales are not spatial, like you were building up molecules to cells to humans. They're temporal durations. And so, for example, my conscious identity has a duration. I can witness it coming and going in meditation. There's a certain rhythm to conscious thought that comes, it's discontinuous if we look at it really careful. So the I that is me is, we could call it reification or coarse grain, but it is certainly identifiable, as you are saying, by a duration. Whereas my fingernails are durable, or their duration is more related to maybe some kind of physical rhythms. So you could think of a duration as a human lifetime for the human body. That's a little simplistic, but that's one movement. What you are working at is a move that process philosophy takes. It despatializes complexity and goes into this sense of things arising and falling with a signature duration. And this is true at all what we would call scales using spatial terms. So that's one thing that it would be great if you continue to think about that, and you'll start to feel more into a process orientation. Now, the other thing you said, and some of this gets hard to wrap your head around because process philosophy is really a different way of thinking. But if you look at coarse graining and fine graining, and so if I wanted to try to explain an airplane at the level of quantum fluctuations, you're right, it's impossible. So we say we're going to coarse grain. We're going to look at things as objects, as persistent in time, blah, blah, blah. But what's interesting when we move down to the smaller parts, if I move from myself to my cells to molecules, we are actually entering much larger domain. Can you see what I'm saying? So, for example, the iron in my red blood cells, the hemoglobin in my red cells has iron in it. And even though I use the term in, this little piece of iron is in my cells, it's actually made in where stars are made, in these cosmological fields. And I would like to think that right now that iron is no longer in that cosmological field, but it is. And so process philosophy is really suspect about what's inside of what. So it seems like that little piece of iron in my hemoglobin is small enough to fit inside of me, like candy fits in a box. But process philosophy doesn't bound things like that. It says iron is a cosmological process, and it exists in this developmental field also that I would call me, but it's still part of the cosmological process. It doesn't cease to be part of the cosmological trajectory of iron itself, any more than the protons in that iron cease to have their signature half-life. And so the categories of existence that we're interested in process philosophy seem to defy this notion of what's smaller and what's larger, because these processes are not inside me as smaller pieces of candy inside a box. They're what we call internally related to me. This is not the same as being spatially inside, and this means that the cosmological process is internally related to me, without which I could not be me. And then there's external relations too. So we switch from insides and outsides, which is a very concrete metaphor, doesn't not adequate to process relational terms, in this notion of duration and internal and external relationships. And we start to stretch out the notion of our participation. So I loved what you were kind of saying, that thing, because if we fine grain, we're actually working with much larger processes. And then we see that the quantum fluctuations are not in the plane. The plane is in the quantum fluctuations, because the quantum fluctuations is much larger domain. It's a cosmological domain. I'm not saying that this is very clear. I'm just trying to give you a taste of how process philosophy can enter into complexity science and some of these ideas of coarse graining and really hybridize and catalyze the field of thought and science.
Okay, let's pursue the example of iron. It's a nice, clear one. We all know, those of us who've studied a little astrophysics, know that iron is indeed created in the late stages of certain larger stars, and we are all stardust, as it turns out. And some of the other ones are only created in supernovas. So we are not only stardust, but we're also supernova dust. And so those atoms of iron were distributed a couple of billion years before the Earth came into existence, probably, in the sun. And those iron molecules, some number of them that ended up being captured by the gravitational concentration that was the sun, ended up being captured in that disk, and some of them ended up being captured in the gravitationally attracted entity that ended up being the Earth, and some of them have been extracted by biological processes and ended up in our cells. I think that's certainly true. On the other hand, it's interesting you brought up time scales, so I think that's really a good tool for differentiating. The activity of cells is on the level of microseconds. The chemical operations of metabolism, microseconds and below that. And so the model of the cell, or the cell itself, if we want to reify it, but let's call it the model of the cell on the microsecond level, is essentially entirely independent of the cosmological evolution of iron. And so if I'm trying to understand the amazingly complex mess that a cell is, I can safely, at the level of microseconds, at the level of metabolism, I can safely ignore very long time frame phenomena like the astrophysical creation of iron. It's just not relevant because there's nothing about it that's relevant. On the same level, the half-life of the neutrons in iron, I don't really need to worry about either, and certainly not in protons. I think last I checked, protons didn't have a half-life. It was at least not clear. So when you're thinking about the time frame of analysis, so that you're not just overwhelmed by way too much detail, it seems to me perfectly reasonable to just say, yes, it is true that iron is part of an ongoing process. In fact, by the way, eventually the Earth will get eaten by the sun, and the sun will turn into I guess it's a neutron star eventually, and maybe it'll get collided with something else and become a supernova, or get eaten by a black hole, and something will happen to that iron. Yeah, that's all true over billions of years. But when I'm looking at what's happening in the cell microsecond by microsecond or millisecond by millisecond, that's just not useful or relevant.
Right. So the move, though, here, and whether we can make it illustrated as profitable, is to look at the scales of duration rather than the scale of what's coarse. Instead of looking at it spatially grained, we're looking at temporal graininess, duration of the cell, what's relevant to its duration, its arising and coming. In process philosophy, another aspect of duration is asynchronous arising and falling. So if all my cells, the cell lives for X number of years, different cells for different years, but my epithelial cells don't live very long. But if all my epithelial cells died at the same time, I would be dead, right? So it's the fact that we are not only working with different durations, but the arising and falling of these durations are asynchronous. And it's why process philosophy can use models and patterns and call them structures and systems, because as an individual cell is born, it's entrained by the pre-existing rhythms of its society of cells so that the structure holds together. It's kind of like the old Buddhist story of, you take a boat and you replace one side and then you replace the other side and then you replace the mast and then you replace the floor, and do you still have the same boat? But it's this notion that the patterns hold because things are coming and going in communion with their societies that are persistent.
Yeah, they're patterns, essentially. They're patterns that are persistent.
Right.
In fact, let me suggest a move. I'd love to get your reaction to this. Instead of talking about space and time, what about if we talk about network and time, right? Networks are topological, and a dynamic network certainly has a time dimension. And again, let's use this example of a living organism. And the definition I chose to use to define the individual is basically that collection of cells which is connected to 1 or 2 second time depth network of nutrients and gases. And that's all a very interesting network. And, Jeffrey West out at Santa Fe Institute has written a bunch of good stuff on the mathematics and the physics of how that plumbing actually works. Truthfully, if somehow I had a cell from my body that was 20 feet away, but it was connected to this near real-time network, I could say topologically and in time binding, it is part of me. So I'm not so interested in space, but rather the network.
It's interesting because in process philosophy, we would talk more about functional relationships. It's really kind of 6 of one or half dozen of another, because you called it a dynamic network, and that's what I would say is functional relationships. It's different than nodes and connection, right? So nodes and connections are like, I can connect training wheels onto my bicycle. I don't know why I thought of that, but those are not a functional relationship. Functional relationship in process philosophy is a relationship that makes a difference in both directions, that constrains possibilities and actually also creates new possibilities. And so if we look at networks that way, we look at the human body as a system of functional relationships that both constrain and enable new relationships or ongoing relationships. So we could say carry them forward. So nothing can stay the same, although the patterns can reiterate. Then we're getting close to the notion of a network and process thinking.
Good. I had a suspicion that putting out the move of thinking about networks rather than space might be useful for convergence of the thinking. And again, just to make it clear for this model analogy we've been using, the network I had in mind here is essentially the circulatory system, which delivers oxygen and nutrients to the cells and takes from the cells waste product and CO2, delivers the CO2 to the lungs to be exhaled, delivers the toxicities to the liver to be further processed and disposed of, and operates in the opposite direction, bringing nutrients from the intestines to the cells and bringing oxygen to the cells. And anything that is not in real time, near real time, 2 seconds, coupled to that network is not a living cell that is part of me. Right. And so there we unify this concept of the identity of an individual as a collection of lower level entities, cells, which are reasonably well defined at the cell membrane level, with membership in a single network, this network of gases and nutrients, essentially.
Yeah, so I think that's sufficiently coarse-grained to be almost like a complicated structure, the way this attaches to that and then this moves to that. But what happens at the interfaces of the alveoli in the lungs and that gas is really very complex. We're getting more into the territory of complexity. One of the things, if we could pivot here and maybe kind of move into a different model, one of the things I like to do is in my presentations, when I talk about self-organization, I show a picture of the ribosome. The ribosome is a very complex intercellular piece of machinery, really, that has no agent in it. It's a subcellular system. It's a very complex piece of machinery. It has to do all kinds of complex things like identifying and detecting and pacing itself and looking at threshold events and microstates. Of course, it's required for the DNA to replicate itself. It unravels. It's a station where the DNA unravels and messenger RNA finds its own positions in there. I'm not really exactly sure about all the terms anymore. But for me, the question is, how does this system self-organize in where it itself does not have DNA? It is the machinery on which DNA is replicated. So what are the principles or the protocols that are guiding this self-organization? And this is, now this to me is where we get into like really trying to understand self-organization and human systems as something that's much more complex than single agent decision making. Something else seems to be going on. So I didn't know if you have any thoughts about that.
Yeah, it's interesting. There's lots of interesting things and hard problems and conundrums around how life came to be. And this is a conversation I still vividly remember having with Stuart Kaufman out at Santa Fe Institute when I first got out there. I think we talked for 4 hours. My own area of scientific true discipline where I actually know something fairly deep is evolutionary computation, which is the using evolutionary methods to do useful computations at the same time using mathematical models to explore evolution. And one of the things that Stuart and I both, had strong congruence on is that evolution of the roughly Darwinian sort, think of it as the machinery, not necessarily the evolution of life, but the roughly Darwinian style of evolution, whether it's mimetic or whether it's software or whether it's life, does not work very well under a high rate of error. And in fact, you can, in a model system, you can accurately determine the so-called error threshold, where when the error rate, called the mutation rate, is above X, the ability to build through evolution is rather weak. In fact, so weak that it's hard to see how a group of chemicals in the warm pond, a la Darwin, could have evolved far enough to produce us in a mere 4 billion years. But somewhere along the line, the whole precision replication technology of the cell, not just the ribosome, but the ribosome being one of the most important ones, but the machinery for replicating DNA itself, error correcting it, making sure that information was replicated at a higher rate than the error catastrophe rate. So, i.e., the mutation rate became lower than the error threshold. Suddenly, evolution became a very powerful ratchet. And the thing we talked about for 4 hours was how in the hell did that very complex machinery get built by evolution from a evolutionary substrate that had a higher mutation rate than the error catastrophe? And we never did solve it, right? Nobody ever has. And in fact, we both left it at damn big mystery, right? In fact, another one of my great mentors, Harold Morowitz, one of the foremost thinkers in the origin of life, written several books on the topic. He, at the end of his life, after working on it for 60 years, also didn't know the answer to that still. And he was still open to the idea that it was panspermia, that that little bit of essential technology may have come from space. And, even though he was an atheist, he also was very interested in religion. In fact, this is quite humorous. He was the scientific advisor to the Cardinal American College of Bishops, despite being both Jewish by tradition and an atheist in practice. He nonetheless was very interested in the religious perspective. And he allowed a tiny little sliver of possibility for somehow something beyond the natural may have somehow helped create this indispensable bit of machinery. So anyway, that was a long aside, but I thought an interesting one.
I think it's good because I think in this conversation we might be pulling out more questions and conundrums than facts and explanations, but maybe that will serve your audience in this podcast really well. So in terms of pulling causality out of space, one of the terms that I've used to talk about causality in truly complex systems is I use the term numinous causality. And it's a little bit of a hedge because the word numinous also slightly connotes something that is either extraterrestrial or metaphysical or religious. There's a religiosity in the term numinous. And I think that it's a good term because you always, as you described your friend, we often get to this place of, well, it must be something in that domain, this domain of mystery or magique, call it magique réalité. But what I mean by numinous is that it's simultaneously everywhere and nowhere at the same time, that we have a sense that there is causality in the system, or that the system has causal implications, or agents are causally implicated with their actions, and vice versa. But at the level of complexity, there is a sense that the causality is so distributed everywhere and nowhere at the same time. But that's just the term I use, this term numinous causality.
Probably a good thing to have a discussion about, because my operational model is to reject all things numinous unless there is substantial proof for their existence.
Mm-hmm.
And so I define my exploration is in the real scientific domain, and attempt at least to see how far we can go with that. Now, as we know, maybe the scientific mission isn't up to it, but so far it hasn't failed. So I resist the temptation that would take what I would call the easy move and construct metaphysical entities to resolve gaps in our knowledge. In fact, fight that fairly vehemently in things that I'm involved with. I think it's, if we look at the history of the human race, it's been one of the things that's held humans back is the easy tendency to retreat to the numinous. Yeah. When yet, and this is, I love to point this out, whenever the numinous and the scientific have collided and overlapped, the scientists were always right. Thor did not cause thunder. Right? Zeus did not throw lightning bolts. Life turned out not to be force vital, whatever it was. Every single time, without exception, when the numinous and the scientific overlapped, it was the science that was proven right, and the numinous that was shown to be just some story somebody made up. And so I strongly resist that move. On the other hand, being of a scientific realist temperament, if somebody can provide real evidence of it, solid, irrefutable, reproducible evidence that there is some numinous effect, which, again, someone like Harold still allowed a tiny percentage for that being the origin of life, probability of that being the origin of life. I'm open to it, but I resist the move early, and I believe it's, looking at the history of humanity, it's been a very detrimental set of tools, because unfortunately we seem to have been evolved to be suckers for it, right? Mm-hmm. People love that shit, right? Even though I go, God damn it, why are they such suckers? I mean, look at the existence of all the organized religions, right? Every single one of them just total pure horseshit as far as I can see. And yet the majority of humans on Earth believe one or the other. And if we believe the anthropologists, there's been 10,000 or more incompatible metaphysical systems that have existed in human history. I'm sure it's way more than that. That's a coarse graining to get to 10,000. They're all mutually inconsistent. Mm-hmm. And yet people live and die and kill for them. So I guess I'm putting up a big slow down when you make the numinous move.
Yeah. So that's, and I think I call it numinous causality because I'm hedging. It tends to want you to go and create a third term, some kind of metaphysical term, but it still has kind of real life causal features or aspects to it. But I'm going to ask you a question. Do you think, given enough time, that the complex systems that we're studying will eventually prove to have specifiable linear or direct causations?
Don't know. I would put down a small bet. I would say, kind of like deterministic chaos, we may be able to show that there probably is something like direct causality, but it's beyond the scale of humans and the whole universe converted to computronium to say anything very specific about it.
Yeah, so that's very close to what I call numinous causality, that it's everywhere and nowhere at the same time. So process philosophy has this cool move. And again, we're not going to be able to solve the problem. I just want to open the search space with this kind of new orientation. So in process philosophy, if you do a thought experiment in process philosophy and you say, what are the most fundamental things I need to start out with to derive this universe as best we know it, all this stuff? Well, process philosophy says you only need three things, and then you'll see I'll get back to the numinous causality. And to your point, your very valid point. So process philosophy says you only need three things. So number one, you need something, even if it's just a placeholder to start with. So you can call it process or potential or some kind of movement, some kind of potential. Our language is you have to start somewhere. So this is just axiomatic. This is our starting place. So process philosophy says process, which is like potential. Number two, you have to have this process has to be self-differentiating. And another way, or a simpler way to say that, it has to be asymmetric. So if you think of it as a field, it has to be self-differentiating, or you can even simplify that and say it has some asymmetry in it. Now, these two alone can create a lot of stuff. A lot of stuff can happen. But what we also need, it could create a lot of stuff, but there would be no awareness without a third term. We would not be aware that the cosmos exists. And the third thing we need is the self-differentiating parts need to participate with each other. So in process philosophy, you can derive the whole universe from three principles or protocols: that there is process or movement or dynamism or creative potential, that it has to self-differentiate, or another way to say that is got to have asymmetric properties, and the self-differentiating parts need to participate so that you have awareness of difference and you have all this other stuff that's in the world. But the interesting thing about process philosophy is once this system gets started, you cannot assume that the original process field or the process plenum exists anymore. It could actually self-differentiate into more and more parts that then are, in relation to each other. In this case, they have the original potential field is all internally related to the parts, which is why we have apparent causality. And so in this case, it's very similar to what you're talking about in terms of deterministic chaos, because it could be the case that you could never trace back the causal origins of the universe because they don't actually exist. It's kind of like, does the first amoeba exist? Well, you can't find it, but it persists or subsists, as Whitehead would call it. So there is a case to be made very similar to what you're saying, is that these complex systems are causally implicated, but the causal origins cannot be found because they subsist. They do not actually exist. So this is another way that process philosophical thinking can understand this kind of important conundrum.
It's interesting. I'll have to ponder that some. It doesn't, again, necessarily strike me as contrary to my own approach, but it might. So I have to think about it a little bit here, and maybe I'll ask some questions. If I were to turn it around and say, where does the universe come from and what is it? Again, taking a scientific realist approach, the best we know today is we had a big bang 13-X billion years ago that had specific attributes to it. Mm-hmm. This specific universe had attributes. And one of my earlier guests, one of the most interesting shows I did, I think, was Lee Smolin, the
Mhm.
physicist who works both on the very small and the very large. And he has a working hypothesis that there are lots of universes, and universes are formed basically out the back end of black holes, etc. And each universe is different, has different laws of physics, different sizes, etc. Some are interesting, some aren't, and he even hypothesizes very loosely an evolution of universes towards a specific sort that are more fecund, and that our universe is probably one of those. And so I wouldn't necessarily sign on to his theory, but I would go one step short of that and say our universe had some specific attributes at the beginning, one of which was a gigantic energy flux.
Yeah, so that would be like my process. Just start with
right?
something. Yeah.
Right. And then I look at Perigogene, right, and his school of complexity, which is, by the way, not the Santa Fe Institute one. When I bring up Perigogene at SFI, people always go, "Ooh, bad," right? And I go, "Wrong," and I disagree. I say Perigogene has some very interesting things to say, which fundamentally is that interesting things only happen in the case, your word, asymmetric, or in his case, energy flows, right? Any system at equilibrium, nothing interesting is going to happen, right? It's just flat, right?
Yeah.
And when there's an energy flux, there's the opportunity, at least, for complexity to emerge into what he calls dissipative systems. And I think this is controversial, but his theory is the universe selects for those systems that can use up the energy flux. And think about that. It's kind of interesting. What is life but a complicated bit of machinery to use up the energy flux from the sun?
Yeah.
So where you would say self-differentiating asymmetric phenomena, he would say energy disequilibrium, which happens to have been a specific attribute of our particular universe. And then physical evolution occurred, but, and this is where we get back to my conversations with Kaufman, only up to a certain level. And we talk about differentiation. The interstellar dust and gases, for instance, are quite differentiated, right? We can find all kinds of interesting and complicated chemistry that has occurred in the interstellar gas, driven by energy fluxes per Perigogene from stars interacting with probably just hydrogen initially, but also now spiced up with the results of supernova. And there's been evolution of sorts, chemical evolution, but at a very slow rate, and it just produces kind of somewhat interesting dust, as far as we know. Then we get to, you can think of all this, another conversation I had on my show with David Krakauer, who defines his field of study as the history of information processing in the universe. We got up to a point where there's some Perigogenian evolution up to a point, but then it kind of stopped, and the universe was a physical thing until life or analogs to life. I mean, there may be lots of life or things that are analogous to life in the universe that we have no comprehension of. But let's just use the one thing we do know about, that life fundamentally moved the ability of evolution to explore new space to a radically new level. Good old Earth without any life had some dynamic, has some complexity dynamic, plate tectonic, etc. But they're not going to produce a 777 or a solar cell or write a Shakespearean play or anything else, or fall in love or anything else. Somehow, again, back to this magical transcending of the era of catastrophe, a bright line appeared at some point, and an evolutionary system that had much greater information processing occurred, and life moved forward from that point relatively rapidly to where we are today. And I like to throw down another bright line that occurred sometime in the last couple 100,000 years, maybe the last 10,000 years, and that is language, which is another new, even way more powerful means of information processing than life itself, which has opened up a radically new domain for evolution of interesting phenomena in the universe. I would compare those two ways of thinking about things.
Well, I think that I like the story. It makes sense, but I think the story cuts the scenes. The scenes are cut too strongly because life is a cosmological process. It's not like the cosmological process is happening in the background. Now over here, scene 2, something more interesting is happening. You can't just, it is part of the duration of the cosmological process itself. Things evolve as a whole. So I think that saying that, well, this was true and in the physiological, the cosmological, physical universe, that wasn't that interesting until life came. These processes are subtended in life itself. It's not like that scene, the way the story was, you told it pretty quickly, but those scenes are cut too quickly. And it's the same with language. Language evolves not on top of life. Language is the enduring evolution of life in the same way that life is the enduring evolution of the cosmos. Those cuts are they're too severe. And I think they're useful. They're useful at a certain level of analysis. Maybe that's a coarse graining problem. But I think when we are asking some of these larger existential questions, those cuts are very unhelpful.
Let me address that specifically. To my mind, when I look at the history of the universe prior to life and after life look very different in the level of complexity which could evolve. And we could look at some smaller cut lines like the specific multicellular technology that was developed around the Cambrian explosion. That's a specific technology that evolved, and once it reached a critical mass, essentially all vertebrate life came out of that one particular innovation. So I suppose what I see is that the history of the universe is contingent and based on some specific inventions along the way, and that on both sides of the line it's very different. Before that Cambrian innovation, life looked very different than it did after. Yep. The universe looked very different before life and after, and I would say that modern cognition, which I'm going to say is coincident with language, looks very different than even Homo sapiens, or if not Homo sapiens, our earliest our close relatives and humans. A chimpanzee is not going to design a Boeing 777, right? A chimpanzee is not going to write a Shakespearean sonnet. It's just completely qualitatively different. And I think that it's actually very useful to look at these qualitative transitions in the history of information processing, and that they tell us huge amounts about what's going on, and maybe even what we should be thinking about as our purpose as a species.
Yeah. So I'm going to argue with you here. This is cool. So, yes, the universe has language now. People don't have language. The universe has language. Without all the background processes, there would be no people having language. The universe is coterminous, continuous in the languaging that people do. This is too hard a cut. I was sitting once with people that actually here. I won't name names. And we were talking about the singularity, and people were kind of computing when the processing speed of AI was going to outdo the processing speed of the human brain. Well, actually, it turns out that's not very difficult to outdo, at least the cognitive processing of the brain. It's not very powerful. But what I said is, so you're going to take the 16 to 42 bits a second that the conscious brain can calculate, and then you're going to compare that to the rate of computation in a machine. Of course, there's no comparison. But you have to include in the human system the information in the ribosomes, the information in the DNA, the information in each cell, the information in the whole evolutionary trajectory of everything that's happened to compose a human, and then calculate that against the computation of a computer, and then there's no comparison. You can't just bracket out this little layer of reality and call that the evolved human. The evolved human is a duration in time. So the human being is, its duration is from the Big Bang to its point in history now. That's its complexity. It's this whole, it's spread out through its whole cosmogenesis. And you can't, and so yes, the mind wants to make a cut. This is completely different. This is Act 2, Scene 3. Now we have humans on the stage. Earlier in Act 1, they weren't on the stage. So this is a way our mind works that's, I would say, structurally reify events away from the processes that generate them. So I could say, for example, what's more complex, the cow or the mycorrhizae in the soil that the cow depends upon? Now be careful. What's more complex?
It's hard to say. You'd have to do the calculations. They're both very complex.
So,
right?
So that's kind of what you're saying. Is the language that people speak more complex than the generative whole that produced people and language in the first place? So in process philosophy, we have two definitions of complexity. We have realized complexity, like the cow, and then we have generative complexity. So the cows could die, and the mycorrhizae would still create grass, and then potentially a new animal, grazing animal, would evolve. But if all the grass and mycorrhizae died, everything would die. So now what we have to do is switch from simple categories to process categories. There's different types of complexity. There's realized actuals, the complexity of language, and then there's a generative complexity, all of which is required not only to originate that, but to uphold it. If the cosmos died, if every element, I don't know what if every quantum fluctuation stopped, there would be no language. It's cool to Google the evolutionary tree now. They have this big wave of a tree, and then humans are at the end. It has extinction events. And then it says in the side, it says, this is the evolutionary tree from the vantage point of humans who are at the end. But if you look at it from the vantage point of the bacteria, they've been evolving just as long, and humans are over here, just this little side thing. So we tend to think as humans have evolved on top of the bacteria, but everything living today, it's evolved the same amount of time, right?
Absolutely. That's a point I make all the time, right? That a dog is just as evolved as a human, right?
Exactly.
They're all, and to your point, archaea or bacteria has all evolved for an equal period of time. However, this is where I think we can use a cleaver to make the cut. Remember, we talked earlier about action, right? Mm-hmm. And what are the actions that these entities can do? Mycorrhiza are not going to make milk, but a cow can, right? And so they have different actions. And humans have, once they transition to language and then science and technology, have opened up an unbelievable action potential, which we're capable of, which we have no idea what the limits are yet. Now, of course, some of those actions are very dangerous, and we're on a road that, if we're not careful, we may very substantially damage the earth and the ecosystems to a degree that in fact, I think it's likely, unless we change our ways, that this is going to happen. But on the other hand, we have the action capability to get ourselves past that problem, I hope, and take us to very, very, very far ways that we can't even envision at this point. And so the action capability on the other side of this quite bright line of language is qualitatively different from the cow, which is qualitatively different from the mycorrhiza. And so that's where I think, and what you say is true. Yes, we're dependent on everything. Yes, if suddenly all the protons decided to break down, game over, right? And I can't tell you that won't happen. How the hell should I know, right? How should anybody know? But I don't really care. From a perspective of the lifetime of a human, I suspect it exceedingly unlikely, so I'm just going to ignore it. On the other hand, our mycorrhiza better damn well take good care of that. One of the things I'm most proud of on our farm is how we have massively improved the soil since we bought it 30 years ago. It was a very depleted mountain farm that had been overgrazed and overfarmed, and we built up back the soils via organic processes for 30 years, and not only do we have a couple inches more soil than we did before, but very active biome in the soil. And oh, by the way, we're producing 3.5 times as much hay as we used to. So I'm very aware of the stack of dependencies. But I would say the stack of dependencies is very different than the affordances that these qualitatively different levels provide.
Yeah, so I like that stack of dependencies. And maybe we can move on to some practical things, because one of the things that I talk a lot about, you may disagree with it, it's useful anyways, I think, in terms of organizations and doing things like improving the soil and working on a farm, is when we get into true complexity, we realize if we have emergent patterns, we could say that healthy cow is an emergent phenomenon from healthy mycorrhizae. That's a bad metaphor. But if we have emergent patterns, it's important to understand that you can't work at the level of the pattern itself. So what I would describe, you're working at the level of the mycorrhizae, is you work at the level of the protocols that is at the stack, is at the lower in the stack of dependencies that then code for the health of the next level. And for me, part of the practicality of working with complexity is to understand at what level of that stack, using your terms, is there the most leverage point? And I think one of the things that we do in organizations and we do in terms of these hyper complex problems we have, like climate or environment, we try to handle it or process it at the highest level of complexity, which is the emergent complexity, rather than trying to find what Daniel Schmattenberger would call the generator functions, what I call the protocols. What are the protocols at which we have most leverage? And so this is a little different than a question. For example, carbon, let's take carbon out of the air, is not working at the level of protocol. That's just working at a level of reactivity. There's too much carbon in the air. Working at the level of protocols is how can we amplify protocols that are self-catalytic so that they then create these generative stacks of dependencies rather than make them more precarious. So I think this is what farmers who are working at the level of the soil understand. There's this great little video, 100,000 Beating Hearts, where this man changed his conventional ranch into biodynamic or an organic ranch. And he found that in doing so, he actually restored the community. He had a local farmers market and a butchery and stores. And basically, he connected the dots that growing the soil grew the community. And so, to me, the field of complexity, its biggest promise is in trying to get us to understand how to improve the stack at the level that is most generative and most catalytic for all the other levels.
I think that's a useful insight, but I would also put a warning. The biggest takeaway, or I would say the biggest change in my personal highest level model of the world from having done a 20-year dive into complexity science is epistemological and process modesty. One of the things that we learn every time we try to examine complex systems is unintended consequences, right? We can't see very far into a complex system. Even a really rich simulation, if it's an honest simulation, will generally be all over the place. Lots of noise in it. In fact, compare that with what I'd call naive Newtonianism, which unfortunately is what 95% of adult Americans believe in, if they believe in anything. That does not foster epistemological humility. We think, oh, well, we can engineer our way out of any problem, right? Complexity perspective will tell us, well, we don't exactly know, but we can have some ideas, and we should look at inputs lower in the stack to have inputs higher in the stack. but we should not have too much hubris that we're right. So we should take an experimental and practitioner's approach to that. In fact, one of our neighbors here in Virginia is a guy named Joel Salatin. He's one of the big developers of soil regeneration and local agriculture at his Polyface farm. He's not a theorist at all, right? He's a pragmatist, and he has tried various things, and his father before him, and over the last 50 years, they've come up with a series of lower level interventions that produce better soil and better pastures and better cattle. He does do meat cattle. He doesn't do dairy. For instance, don't use broad spectrum herbicides, use organic nutrients in the soil. Don't pasture for too long. Use multiple species with short duration on any given thing of pasture. These were essentially experimentally derived protocols, which took him, he and his father 50 years to develop. And I would say that's an honest complexity perspective, rather than someone coming in and saying, all right, this is what we need to do, blah, 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 and blah, because there's a good chance that they're wrong.
Yeah. And also, all these experiments, when you're working at the lower levels of the stack, it's all very context dependent, right? So the mycorrhizae in this area versus the mycorrhizae in that area versus the phase in which your land is going through and its history. All of these things are local context. And so we need a lot of these experiments in many places, happening in many places all the time, rather than some kind of best guess at the global intervention that we as a species should do. I think this is a very good point that you're talking to, and I think that it's funny that people like you and I and your neighbors and my neighbors, after all our intellectual hubris, let's say, instead of modesty, that we are working on these kinds of experiments and learning something about our environment anew. And for me, like I did landscape design, build, and construction for 30 years, and we built beautiful gardens for the rich and famous, ones that look like Versailles and were both ornamental and food production. But it was so labor intensive. Like, this whole approach was so labor intensive. And then I worked on a biodynamic farm, and I thought, oh my God, you'd have to be a masochist to work this hard. The farm had fairly poor soils that had been grazed. And so for years, just moving from one failed experiment, let's say, to the next. And then we purchased this property here, and I set out some nice vegetable gardens and herb gardens, and we have horses. And I would notice every year I'd go up to the second year poop pile, and there'd be tomatoes growing as big as the trees in there, and without any kind of cultivation at all. And then I started doing experiments and noticing how if I planted pumpkins, the tomatoes would follow the pumpkin vines down the poop pile. And so finally, I don't know why it took me so long. Finally, I just said to my husband, I said, let's just take 2-year-old poop and throw it on that field. Let's just do that. And I have like a half an acre of self-seeded tomatoes. I can't possibly eat enough of them. I don't water it. I don't do anything with it. And I have pumpkins and acorn squash growing up the trees. So there's somehow that we are still learning this again for the first time, or maybe we never knew it. I don't know. But it is kind of humbling to think as a species we are learning this again. I guess I always assumed we used to know this.
Obviously, our ancestors knew it as a form of practice to a greater or lesser degree, though on the other hand, the historical record is full of people who overshot their environments and died, right? Mm-hmm. What's his name? Diamond's book gives some good examples, and there's many others. The Anasazi in the Southwest, it's just again, humans temporarily reached equilibrium with their environments, but unfortunately the Malthusian march of population very often broke that. In fact, one of my friends, George Gummerman, a very distinguished archaeologist, said, truth be known, most primitive peoples, especially once they developed agriculture, way more often than not, lived at the edge of starvation.
Mm-hmm.
Because the Malthusian March was always pushing it to the degree they made some breakthrough in understanding their local environment. Then they replicated too fast, and oops, there we are, just ratchet ourselves up to a bigger problem. One of the interesting things about our current epoch is we actually finally broke out of that for a short period of time. We actually were able to more rapidly build food than we built people. And it happened in two dimensions. One, our scientific knowledge and our engineering practices allowed us to very rapidly ramp food productivity. And miraculously, birth control got better
Mm-hmm.
at about the same time, as well as this curious, interesting sociological phenomena that as people get richer, they want to have less children. And so we're now on a trajectory, finally, to a stable population and probably a declining one. But unfortunately, it's too damn high at 10 or 11 billion people. But at least we have given ourselves this short period of time of freedom from the Malthusian ratchet to try to build the tools to get to the other side.
Mm-hmm.
And that seems to me what is, just to change directions entirely here. This seems to me what I'm so interested in right now is the people who are doing serious thinking about what comes next. What social operating system, what does it need to look like? And again, informed by complexity and informed by, I would strongly recommend, epistemological modesty. What set of experiments should we be running that we can evolve towards a stable version of what comes next, which preserves all the great things we've created over the last 400 years, but navigates them to something that's truly sustainable for at least a few millennia. And that strikes me as the number one challenge of our time.
Yeah, and I agree with you. I think I often comment on the expectation, anticipation of world population peaking. I often like to think of what affordances, what spaces and potentials will be open when it actually declines. If it has a generative decline, a complete crash obviously could be problematic. I think that also because we are complex life and life operates at the edge of chaos, far from equilibrium, I believe that projection is right where it must be at maximum, whether it's just slightly overshoot or not. It seems like as a lot of living systems, the trajectory toward that peak and the instability that it's going to be encountered up to that peak are right there at this very thin thread at the edge of chaos. That's a story, it's a mythology, but I think that it actually gives me hope, this projected release of population, exponential growth in population. Of course, there's a lot of local turbulence that happens because of it, a lot of migration, a lot of implications for economies and stuff. But as a broad story, I really find optimism in that. And and so what is possible? Should we be designing today for that anticipated future? Designing not only to survive this transition phase, to survive this exponential complexity, all these increasing pressures on the system, but maybe that's the world we design for. We begin trying experimental design for today, after the peak population.
Yeah, I think that's a useful thought. And of course, we're running the experiment right now. I mean, there are already countries with declining population. Germany, I think some of the Eastern European countries, Romania, Bulgaria, I think the Czech Republic and the Slovak Republic are declining. Japan is just transitioning to decline and will go very rapidly into decline, as will Korea. And then China not far behind that. So we'll actually have some real-time experiments on what stresses do declining, and then, of course, fortunately or unfortunately, the very big change in the age pyramid due to its society. So we can start running those experiments right now. And it is potentially hopeful that on the other side we have more room when, so let's say we could, if over a period of a couple hundred years, build our population down to 2 billion or something. At 2 billion, we could actually run a Western quality of life with fully organic farming, probably, right? And we could certainly run a carbon-free energy system, et cetera. Probably can't do those things at 10 billion. So it's hopeful to know that there is another side. And on the other hand, we may not, because that's the backside, but perhaps more immediately important is how do we navigate over the next 100 years to that peak without crashing the system? Or at least that the crash be relatively small. I mean, we talked about this on the podcast where I was the guest recently, that fortunately, collapse scenarios seem to follow a fat tail distribution. Both fortunately and unfortunately, it means that there's going to be more collapses than Gaussian thinking would lead us to believe. But on the other hand, there'll be more smaller collapses than big collapses. And so, maybe we have a collapse where 10% of the world's population dies, and that provides a breathing space for the system to then start to recover. And these collapses aren't always bad in their outcomes. The famous one was the Black Death. Killed a third to 40% of the population of Western Europe, and many historians point to that opening up as what brought the end of feudalism, the beginning of freedom, and the beginning of the modern world.
None of them are bad if it doesn't happen to you. But I think, like, putting together what you said before, this is why we have so much pressure on boundaries and immigration now, because there are countries that are being able to experiment with declining populations, but the world as a whole, there's osmotic pressure for populations to migrate to lower population densities, and so those experiments are complicated by the movement of the whole. And I think that's a big code to crack. How are we going to deal with that? Are we going to try to stratify those movements? Are we going to try to ameliorate them on a global scale? I mean, what's your opinion about that?
That's a very interesting and major problem that we have just started to see the very beginnings of now. I mean, most of the migration today is not caused by, at least not directly caused by reaching the limits of the ecosystem. Most of them are caused by war, right? Or civil war, internal conflict. Syria being the biggest example, but the Congo being another gigantic example. South Sudan being another one. Those are not yet climate or Malthusian-driven migrations. Those are side effect conflict. But by 2050, 2060, we're going to start to see, assuming we don't change our ways as much as we should or need to, massive migrations from places like Bangladesh, and where climate change, rising sea levels, perhaps major famines in parts of the world, including possibly China, driven by climate change, that will be on a scale that makes these current things look like child's play. And the decisions that societies take are going to be very important. On one side, humanitarianism says, maybe we should take in these folks. On the other side, as we're learning more about what makes society work, there's a real danger of producing decoherence in a society. We're seeing it in Western Europe quite substantially today, and to a lesser but still substantial degree in the U.S., where neo-fascist tendencies are arising in reaction to the perceived decoherence of society. And that's something to take seriously, I believe. So it's a damn difficult problem, and I don't know what the right answer is, but fortunately we have a few years until it becomes really significant. We have this preview driven by conflict to sharpen our practices around.
Yeah, and as you say, even if the numbers aren't great, the perception or the way people are experiencing just this amount of migration is really quite exaggerated or quite severe.
I don't know if it's exaggerated or whether it's not. I mean, it depends what value you put on social coherence. And I think there's a lot of current thinking going on amongst independent thinkers that social coherence is more important than perhaps we've been giving credit for the last 30 or 40 years, and that it may argue for smaller polities of higher coherence. And that then has to be overlaid on the problem of environmental migration that'll be facing us 30 or 40 years from now. Because if you have a big polity, trying to have coherence is difficult.
I posted a video from Mark Blythe, and he sees that with some of the political changes that are happening recently, that there is a hope that different nation states will run different experiments, so that China has its own approach to some of these looming crises, that the U.S. will run its own experiment, that Europe will run different types of experiments. And he sees this as very hopeful instead of the whole globe running one type of experiment to address these potential crises or these looming threats. And I was very encouraged by that.
Yeah, I think that's great. And I regularly speak out against the idea of a world government for just that reason. I say I'll be willing to consider a world government when we have 5 worlds, right? Because we have to have diversity and we have to have the ability to compare different approaches. What we don't need is a world government, but what we do need is world governance, which is kind of interesting, right? We need to manage the world as a commons amongst a series of independent entities, whether they're nation states or smaller level entities. And people get those two things confused. Way too often, people who see the need for governance make the move to one world government, which to my mind is a likely prescription for disaster for exactly the reasons you just laid out, which is it produces a very large possibility of making one bad decision rather than experimenting with multiple ways to solve these problems, and presumably the better ones then are adopted by people as they're proven.
Yeah, it makes me think of one of these design principles that comes from designing for emergence, this notion of maximal decomposability. So, for example, the human body cannot be decomposed back to its cells and then have it recompose itself. And so but there are certain generative ecosystems can be decomposed into many, many different types of environments and still regenerate themselves. So, for example, my pond is a beaver pond, and slowly it silts up and will become a meadow, and then it will become a forest, and then the beavers will come back when there's enough food for them and start destroying, quote unquote, the forest, and then it'll return into a beaver pond. And so it can be decomposed. The set of relations can be decomposed over and over, and it can still recompose itself. And so this notion of distributed autonomous organizations, or Christopher Alexander's notion of living centers, is a design principle based around not only having ecologies, but that having the parts that are in this ecology of the whole being able to be decomposed back down to their own autonomous selves, rather than having the parts be related to the whole, such that no part can recompose itself from its own self. So this is an interesting question. What is the maximum decomposable part of human civilization? We know it's not an individual, right? So there's a low limiting constraint there. But we can ask that for in relationship to a set of principles. So what is the maximally decomposed unit that a human system has to be to have this standard of living and these freedoms, let's say, and build around that kind of design. So we're designing for distributed systems, but that they need to be wholes unto themselves.
Yeah, I think that's extraordinarily interesting and important question. And it depends on whether these are open systems that trade or whether they're autarkic, right? One of the phenomena of the last 40 years has been the very rapid growth of international trade. Most people don't know this, but actually international trade hit a very high point before World War I. 25 or 30% of the world's GDP was in international trade. It never recovered from World War I, and it didn't pass the 30% mark again until the 80s. Now it's quite a bit higher than that. So we have a world that it's very deeply interconnected in ways that are both economically efficient and very dangerous from a systems collapse perspective. And so when you're asking at what scale can there be a autonomous group of humans, if we assume they trade with each other, it can be quite small, right? If we assume that they're autarkic and they have to create the whole stack and manage it themselves, then it has to be much larger. So I would turn that question around. But I would also say that my own preference is not to go to autarky. That has not been shown to work. That ends up with the world of North Korea, right? Which has really smart, energetic people who have been absolutely hobbled by a doctrine of autarky. The nice thing about it from a coherent perspective, if we assume trade and interconnectedness to some level, it allows us to have higher coherence in the units. Let's say that the unit size let's say we can get the unit size down to 100,000, and as long as we allow trade and flows, we could, I think, almost certainly do that. At 100,000, we can probably have a standard of pretty damn high coherence, particularly if we allow and encourage migration. Hey, you don't fit in this polity because of our agreed upon core values. Going to move to one where you do fit, right? I think that move it releases a lot of pressures. If you have a continental class nation state, the tendency is to try to coerce those who disagree, right, with the core values. If your average polity size is 100,000, and then we could be very much like the hunter-gatherers. One of the things the anthropologists have found is that the hunter-gatherers have a lot of people that leave one band and join another because they disagree with the culture, or they get into a pissing match with people. And so, having a smaller autonomous unit that, say, in the 100,000 or less size, that is viable because of trade might well be the right way to balance these two. But it's a question that we need to be thinking about here as we try to figure out what comes next for our society.
So, and that reminds me of these other principles of it'd be interesting if we could come up with a design toolkit that had this notion of universal access, so people could move around, but each autonomous organization would have some kind of self-organized criticality, so that beyond a certain scale or dependency, it would have small crises, small collapses, and stay robust, but that people could move in between these domains, these self-organized critical domains, through universal access and trade, right? So through actual movement of people and also movement of goods and services and financial instruments. So that's kind of interesting. It made me think about that in terms of.
Yeah, I like that. Because again, if we have, let's say the United States consisted of, how many would it be? 3,000 units of 100,000 each, right? If a couple of them went bust, right, completely failed, so what, right? All the rest of them could just absorb the refugees from those, and life goes on. Nobody dies. A few 100,000 people have some disruption in their life, but the system is robust to a sustained rate of failure, essentially. And of course, there's also comparative competition. Some polities will have better operating systems than others, and the word will get out, and people will migrate towards the better ones. And assuming we concluded something like 100,000 is an optimal size, some of my discussions with Daniel Schmattenberger, I've strongly suggested that we build fission into the operating systems. Right, when a polity gets too big, it ought to decide to fission and divide into two. This is something we know that hunter-gatherer bands did as they started to exceed the Dunbar number. They fissioned into two polities, and I think that's a very useful design principle to keep front and center as we think about designing this kind of more decentralized, autonomous world.
Yeah, and I think that's a way to have, as you said, much greater local coherence amongst these 100,000 and have a less precarious situation.
And again, going back to the hunter-gatherer model, because one we know that worked for millions of years. If we have these polities, they're not going to be arbitrarily, randomly selected. They're going to be related to each other at some level, right? Let's use a word I think you and I are both familiar with, game B, right? Suppose there were a game B set of polities, right? Let's say out of the 3,000 American polities, 30 of them were game B flavor, right? That had emerged out of a original operating system and had fissioned or had been developed independently. If one of those were to die, quote unquote, the refugees could go to the other game B polities that would be quite similar to their previous homes.
Or you'd even learn something by its failure, right? So the whole would learn something new. Oh, okay, so that didn't work. It was not what we anticipated. These are all dynamics that cut against the grain, certainly of game A and civilization building as we've known it. We've been on a long trajectory to globalizing, larger and larger geosocial spaces. We have only a handful of nations now. We have one global currency, with the exception, I guess, of North Korea. It used to be Libya too, and maybe Iran, I'm not sure. I mean, this whole movement is also in the ideology and the mythology of, let's say, I tried to get through this interview without saying it, but in the postmodern ideology, neoliberal ideology, that everyone needs to be one community and one global value stream and one global experiment, and that we have to have these centralized global interventions for these global problems. I mean, what do you see is the reason why we have this ideology? We can't seem to get out of this ideology of some kind of global unification.
Yeah, it's a damn problem, because unfortunately, game A has defeated all alternatives, right? It's defeated it in some pernicious ways and in some good ways, right? It has raised standards of living faster than anything ever has, right? But it's also invented psychologically informed marketing, for instance. A part of this growth has been in invented needs. In fact, at this point in the advanced world, probably most of it's invented needs, right? Who the hell wants or needs processed food? The crappy shit that they sell on the shelves at grocery stores, right? We don't need that shit, but somehow we've been convinced it's good for us, or that it's status seeking or something. Who the hell needs a $125,000 automobile? Nobody, right? But through psychologically astute marketing, we've convinced lots of people that they do. And so a lot of this so-called standard of living is bogus and kind of endogenous the bad games that game A plays on reprogramming our autonomous selves in detrimental fashions. But all that said and done, it's beat all comers so far. And so the challenge, and let's be specific, talk about game B. People we know are trying to play game B, and we're trying to help them. Game B has got to be able to beat game A, at least in the microcosm. And I believe that particularly Daniel Schmattenberger got some very good thinking about this, Daniel Jordan Hall as well, and some others, is that it's may well be that this unfair competition of game B is in true quality of life. I've really taken to the term, I think Jordan tends to use it more, conviviality. We are basically apes with clothes after all, and we really want to have a healthy life of the group. Think about how many, it's a scary statistic the other day that more than 50% of the people in Manhattan live by themselves. Like, what the hell? That's unnatural, right? Humans that live by themselves die, both physically and mentally. And how many people, I read somewhere that the average American has less than 4 friends. I go, what the hell? That's sick. If you lived at a Dunbar level band, you'd have a couple of dozen friends, probably at least a dozen, and you'd have a fluid, convivial way of life that I would expect people would find vastly more attractive than this atomized, programmed by marketing, dominated by scale, accelerated by finance beast called Game A. But we also look at the history of these utopian type movements, and we know they mostly fail. They mostly don't work. So it's a really difficult engineering problem here to create a social operating system for a Game A that can operate at a small scale. And my conversations with Daniel, he and I both, I think, came away with a sense that a scale of around 2,500 might be a good place to start. Again, assuming open, semi-permeable membranes, trade interactions, and frankly, to some degree, parasitizing Game A. But within the bubble, within the membrane of the Game B first entity, the quality of life would be so much better from the actual experiential perspective that we'd actually have an osmotic pressure of people wanting to come into Game B and relatively few people wanting to leave Game B. That would be the correct measure that we've gotten this operating system approximately right. Though again, I do warn these operating system designers, we got to have complex systems humility here. The version 0.1 is going to be wrong, right? And we better be thinking about this as an experiment and not as a doctrine. If any of this stuff becomes ideology or cult of personality or rigid, it's going to fail like all these other alternatives, right? It's got to take a complex systems, evolutionary, learn by doing perspective.
Yeah, and I would hope that if we could have shared anything today with the audience, it's about having experimental attitude, but also having curiosity within the realm of ideas, because I think that we have paid a premium price on limiting our ways in which we can ask questions, ways in which we conceive and model the world by some ideological assumptions that I would say have led to Game A for good and are now constrained by Game A and kind of constraining us as people. So I think that we kind of modeled an exploration of ideas, and perhaps we're looking for both action to inform new ways of thinking, but also new ways of thinking to come up with different design principles for action. And I think that's what you and friends of ours are putting their effort into.
Very well said. I think on that note, we will end here. This has been wonderful. I was expecting this to be an interesting conversation. And I love the move that you made to compare and contrast process philosophy and complex systems thinking. And it's going to make me go back and do some research.
You know what I hope, Jim, is that our audience will start filling in the blanks for us. So hopefully it's provocative enough that we get some new ideas that we couldn't think of ourselves, like from young people.
Yeah, exactly. Production services and audio editing by Danton Media Lab. Music by Tom Muller at modernspacemusic.com.